a path.
Yeah. So flow of electron, right? Correct.
Sir,
Yes,
not only electrons, we should write charges, right? So
exactly. Flow of charges. Now, if this is a circuit, I'm just drawing a standard circuit. Now, flow of electron and conventional flow of current, both directions are opposite, right? This flow of current,
yes.
like it is moving this direction, and flow of electron, opposite direction. Conventional flow of electron. They both are in opposite direction. Okay, so before going to circuit, so first of all, what is electric current?
The flow of
electrons through a path.
The flow of electric charges through a circuit is called an electric circuit.
Yes. So flow of electric or charges through a circuit or electric. Flow of electric charges. Flow of electric charges.
Then
So-
electrons are negative charge, right?
Yes, electrons are negatively charged particles. Actually, there is like they gave a name, so we can say there are only two charged particles.
electron, proton.
No, positive and negative.
Yes, a
Yes,
positive,
sir,
negative.
positive and negative.
There are only two charged particles.
Sir, positive and negative.
Positive charge particles,
Negative charge.
charge
Negative
particles.
charge.
Positive charge particle possess proton,
Negative possess negative.
electron.
It's electron.
More electrons. More electrons than protons, right?
Yeah,
So anion, cation.
yeah.
Wait.
So charge of one electron. You know what is charge of one electron?
No, sir.
1.6 into 10 to power minus 19 coulomb. That is minus. Same charge for proton. 1.6 into 10 to power minus 19 coulomb.
Sir, what is the value of C, sir?
C is charge, it's a unit.
Okay.
Sir, electron is minus 1.6 and plus 1.6.
Minus, proton
Yes,
plus. So charge unit is coulomb. Coulomb is denoted by capital C. Whenever we write capital C, it denotes it's a name of scientist.
Sir, Coulomb means?
It's a name of scientist. It is unit of charge. So as we wrote, what is the unit we are writing, right? So meter is the unit of length. So if I ask you what is the unit of length?
Meter.
Yeah.
Unit of charge is coulomb.
Yes, unit of charge is coulomb. Or coulomb, whatever you pronounce, fine. So coulomb is given by name, scientist name. So that's why we are writing capital C. Meter is not given by scientist name, so it is small c. Kilo also small.
Small limbs.
Newton, we are writing capital N.
So, like, these are the formulas for electrons.
No, this is not a formula. This is a value for electron. Charge of electron, this is proton. One electron contains this much charge. One proton contains this much charge. Okay, I
Okay,
think I
sir.
went a little bit outside of your syllabus. No, in flow, I'll see so many things outside related. That's a bad habit of mine.
So,
Okay.
like, could you increase your voice? I can't hear your voice, sir.
Is it clear now?
Yes, sir.
Okay. Now, if I ask you what is where this current is flowing, where's the previous slide? Okay, yeah. So current is flowing in this circuit, right? So then again one question arises. Now, what is a circuit then? What is circuit?
The flow of electric current.
The
Yes,
circuit
sir.
is
What is
Sir,
circuit?
it's a part of the flow of electric current.
Yes, sir. It's a path of the flow of electric current.
Okay. So if I say
the
it's a part of
circuit is
electric,
a combination of this cell, wire, and I don't remember what the other one is.
okay. So you are saying,
The load.
okay, let me draw here. Then what else? This is circuit now.
So that's a
A closed
resistor. Right?
circuit. This sir is an open circuit.
But whatever you said, I'm drawing it. A resistor we have, load we have everything.
It should be connected from the negative to positive terminals, and there should be a switch.
Exactly. No, switch is not a problem, but there should be a complete connection. So how can we say this is the only the circuit? Like, why can't I say this is the circuit? Because it is
So it should be
not
connected together.
exactly. We need a closed continuous path.
Sir, in order for the current to flow, the circuit needs to be closed.
Closed. So this is not the circuit. Let me draw again. So when can we say it is circuit? When we have closed.
So I think someone is unmuted.
Okay. Yeah. Muted. So we need closed continuous path. Then only we can say it is circuit. So how to define circuit? Can you
Sir,
give me
the
one
path
statement?
of
So it's
flow
the
of
part
electric
of the
flow of
electric current
electric
which is
current, sir.
closed.
Sir,
Yeah.
it should be closed in order for the electricity to flow through it.
Exactly. So in that, what we need? There
So for the
should be one
continuous flow of
source.
electricity.
Yeah, there should be
So
one
source
source.
of current, sir, like a battery.
Source of electrons. Right?
Switch.
Yes, sir, source of current like battery or cell.
For that, what are things we have? It should be starting and ending. Means it is should return. Starting and ending, entering and leaving. Electrons will enter and electrons will leave from the circuit, like a source. That is a source. If I ask you what is a source, what is source? It starts and leave. It starts from there and leave and enter somewhere else from the other terminal.
The starting part, like it is the starting point where
Yeah.
the charges start and end up again.
Yes. So I can say closed. Closed continuous path. That is electric circuit. Now, one more question arises. Then how can we say it is open circuit or it is closed circuit?
Sir, like if the source of current, like it is cut off, then the bulb won't glow, sir.
Sir, if
If bulb
we have a
will glow,
bulb
it
in
is an
the
Sir, if the
circuit,
bulb glows, then
should
it's
glow.
called a closed circuit, sir.
So not only bulbs are
Sir, if the
there.
load is working, then it's a closed
Yes,
circuit.
sir.
Okay. So let me draw.
or we can use a multimeter, sir. Excuse me, sir.
Yeah, I'm listening.
Sir, can we use a multimeter to measure the charge?
Yes, we can measure.
Sir, but multimeter tells the charge.
Yeah. So these are the two circuits I'm drawing. So how can I make this as open and how can I make this as a closed?
Sir, you can connect the wire through the switch.
So this is the key. If I place this, it is open or closed?
Sir, close.
Closed.
Closed. Right.
Sir, a piece of wood.
So this should be unlike a switch off condition means this is this way. This is called switch off condition, open key.
You have to put a dot inside.
Yeah, this is closed key.
Yes, sir, in the book.
Yes, sir. It's like they show like this, sir.
Yeah. Order this resistor. And this one,
Battery, which
battery.
is made up of
Battery.
cells.
Sir, it's a source of current.
Now
Sir,
for-
it's a cell only. I think it has only 2 terminals.
Yeah.
Cell.
So the long one is positive and the small one is negative.
Negative.
Negative. Now, what are other symbols you know?
The bulb.
The
You know-
bulb, it's the curly line.
What are this?
Sir, first
Yes,
one
sir, this is a
There
bulb.
is second one is bulb.
Okay.
Sir, second one, the bulb is glowing, sir.
Bulb. And first one?
I don't know.
Ammeter.
Yes, sir. Ammeter.
Ammeter is the instrument to measure the flow of current. So how much current is flowing in the circuit? It is measured by ammeter. Yes?
Sir, in my book, switch is shown in a different way. It's a simple line.
Yeah, like this.
Yes,
Yes,
sir, like
that
this.
is switch. That is closed. To.
That is switch. This is key.
It's
Both.
open, sir.
No, this is key and this is switch. Both are same. Both
Okay.
work is same, but we have different way of use. This is open.
But when we're drawing a power source, don't we usually have to give another long line and short line?
I'm sorry, what? I didn't get you.
But when we're drawing the power source, so here you have drawn a fairy. So don't we have to add another long line and short line, and the second short line should be connected?
Do you want me to draw
Sir,
other one?
that becomes a battery then. This single one such cell.
That doesn't mean that doesn't matter. It's not a big deal here. Okay, so this is our battery. Fine.
Sir, we can, sir, for volvometer, we can keep V in place of A, sir.
Yeah, so that is switch. This is open. This is
Open
closed.
switch. This is closed.
Now we have one more thing that is left. That is
Fuse.
V, voltmeter.
So even fuse.
Yeah, fuse also.
Sir, capacitor.
Do you have voltmeter in fuse in your syllabus?
Yes,
Yes,
sir.
sir, we have.
So
it.
we had.
Very good. Then we can discuss that also.
Sir, we
Yeah,
have.
but
MCB
this
and
year we
meter
did not
reading
have. So
also.
last year for 7th class we had.
Yes, sir. For 7th class, I think we had, sir, but for 8th, we don't have, sir.
Fuse symbol is very simple. Just like this.
Yes, sir.
Okay. Okay, let's get back to our circuit.
So can you again explain ammeter and voltmeter?
See, ammeter V is instrument to measure voltage in the circuit. Okay,
Sir, capacitor.
I'm sorry, I said wrong. Voltmeter is the instrument to measure voltage in the circuit. Ammeter is the instrument to measure,
Flow of it.
yeah, how much current is flowing in the circuit, current flow.
Sir, then what is
Okay,
the difference between multimeter and ammeter?
Now see, multimeter works for everything. That's why its name itself is multimeter. It is for everything. It will measure voltage, current by just changing a switch. It will change to current.
Yes, sir. I have it in my.
Have you seen that? Like, let me show you one picture.
Yes, sir, it's
It will be like
typically yellow
it will be
color.
round, sir. The switch will be something.
Sir, and it's typically yellow colored.
Yes, sir. I have it in my home.
Yeah.
I do have that.
Just let me get one picture so that I can discuss with that. Array image I don't want price. Okay. Can I paste you a picture? I can't. I can't see a picture in OneNote or what?
Sir, you can paste.
Oh, it's not coming here. Pasted here. That's why I like OneNote. Better option is always OneNote. No, I'm not able to.
Sir, I have it right now, sir.
Okay. Like this. It will be like this.
Yes, sir.
Sir, like what is the difference between voltage and capacity of current?
See,
Sir, I think that ammeter tells in ampere and voltmeter in volts.
exactly. If you can see this part. Oh yeah, see, he's also having. Yeah. Let me stop sharing. Yeah,
Yes,
you
sir,
can
I
see
have
him.
that type.
See, I have spotted. Yeah. You can see this. Yeah, see. Okay, so what we'll do, this he's holding that black and white. So just we'll put in that. We'll just place there. Yeah, wherever we want, like whatever we want to check. And it's already connected. See the red connection here in the bottom. And now it is in off condition. If you see, if I want to check current, I'll just move it on the right side. Is it on right side? Check. Is it your current is on right side or left side? For you, Sita? No, you just see and tell me. It is on left or right? What is on left? What is written? Something written on left? Left. Your left. You are muted, boy.
The left side I have something like V.
Yeah, that shows voltage. And where is ampere? Where can you find ampere? A.
Sir, here, sir. A.
Yeah, see, if you just regulate this to the A side, you can regulate your current, how much current it will be. Same manner, this is for voltage. If you regulate on the left side, one more, this is for ampere. If I want to measure ampere, and same way regulate for left, two times left. Move the regulator 2 times left. One more. From the off, yeah, one more, yeah, that's it. So this is for voltage. And there are number of voltage here. We can see that number of voltage. Fine. Yeah. Okay. Yeah. Thank you.
Yes, sir.
That is
Yes,
multimeter.
sir.
That's multimeter. So name itself says multimeter means used for multi-purpose. Okay. Fine. Let's get back to our topic. So where are we? Correct. Circuit. So if I go with circuit, there are 2 types of circuit.
Sir, closed circuit and open circuit.
Close and open. Now in that also we have 2 types of current flowing, alternate current and direct current.
Sir, can you please tell how is this conversion of current done AC to DC?
Yeah, we'll see that. So first let's go step by step. Alternate current and direct current. Now, what are alternate current and what are direct current? Have you heard of these 2 things?
Yes, sir.
Okay, so what are alternate current first of all? Or sorry, let's start with direct current. What are direct current?
Sir, in that straight movement is there. Directly the current reaches till the load.
So in direct current, we can't, like, using any device also, we can't increase it.
Yes.
But in alternating current, if we use like a transformer or something, we can lower it.
Yeah, we can reduce, we can increase, whatever we want. Right? Okay, so any other thing?
But in
Yes, I want.
direct current, it will, remain constant all the time, but alternating current, it will change.
Just same. Okay.
Sir, our regular cells and batteries have which current, alternate or direct?
That is direct
Alternate
current.
current.
No. Batteries. They have direct current stored. See, in short, we can just conclude one thing small way, like whichever which is stored for some time, direct current. That is direct current. And which is not stored, like which is flowing, and which is alternately moving here and there. See, actually, if I want to tell you, like I don't know you can understand or not. Let's try. Actually, let me draw a graph here. See, this current versus like how current is with time. So here, alternate current will always flow positive for and negative in one cycle. That's why its name is alternate. It flows to the positive cycle and negative cycle alternately.
Yes, sir.
But whereas direct current is just a standard form, it is constant, it is not changing. That's why we are in this direct current, generally we won't get shock until it is converted.
Yes, sir. Yes. Sir,
Yeah.
our phone and laptop batteries are a direct current, right?
Batteries are direct current, yes.
Okay, sir. Thank you.
Yeah. So if you have observed, they are writing lithium ion batteries,
Yes, sir.
AAA batteries, or A plus batteries, whatever it is, HW.
So what are the difference between these four types of batteries, sir?
No, like they have given standard names for like some for cell, some for remote control, some for some other purpose. So they were given these names. This is for multi-purpose. HW battery is for multi-purpose battery because
Yes.
Yes, sir, that radio one, blue colored.
exactly.
Yeah, okay. I have one right now.
Yeah, it will be like this. You can use anyhow whichever way you want. Some are alkaline rechargeable battery, which is rechargeable. Generally, we are
Sir,
this
lithium ion batteries are in laptop battery.
exactly. So they have different purpose of use. Like somewhere remote control.
So like, can you explain direct current again?
Yeah. We'll go back to direct current. So what happens with direct current? How it is generated for alternate current? First of all, see, alternate current is generated by turbine and like all that power plants. Power plants will generate, or in short, we can say generator. It will generate current. Okay, then like it is passed through the transformer to our like big station, then big station to our small station, and small station to our nearby transformer. If you have observed near to your house, there will be some transformer.
Sir, I didn't understand. Can you repeat the topic?
Yeah. See, when like if you have seen, like let's take hydro power plant.
Sir, hydro?
Hydro power plant. Hydro means water.
Yeah, sir, I know.
Electricity from water.
Power plant. So like from there, with the flow of water, what they'll do, they will rotate turbine.
Yes, sir.
They'll rotate turbine. Okay. Once turbine is rotated, and due to the rotation of turbine, and generator will move. And generator will move inside the, like there will be connection between one shaft. There will be one shaft here. Okay, here turbine will rotate and generator will generate electricity from here, and which is passed by this. This electricity is transferred by power lines, which you are seeing overhead lines. Have you observed the overhead lines?
Yes, sir.
Yes, sir.
Mostly there will be so big tower, like so huge tower. Okay, so big tower, and there will be one like for power transmission. There will be big towers like this.
There are lots.
around.
Yeah,
They are large around the cover.
exactly. So they will transfer here because, and this tower should not be near to your house because something bad happened to your in this tower, something wrong like overheating or something, and it will affect your our house and nearby
There is
thing.
huge one.
Yeah,
So that's why they're
But
made
they
it in
are in
open
farms
place.
generally.
yeah. Generally, they are in farms.
In open places also.
Exactly. So from there, power is generated. That power is electric current. That is electric current. So from there, it is transferred to ours like a big station. First, it will be big hub. There will be one big station, power station. Then near to, excuse me, near to your house, there will be one transformer. From here to substation, power station.
And so then there is DB, distribution board.
Exactly. So they will, substation is the distribution board. It will, this is substation. It will distribute to your houses. So how it is distributing? Near to your house, there will be one transformer. Like this, if you observe, like one big transformer will be there. So now the question is how they are transferring. It is, this generation is not just 1 or 2 or 3 kilowatt. It is 100 megawatt. So mega means like so much. Some power station will be 1 megawatt, some will be 100. So in short, we can say at least minimum 1 megawatt. So 1 megawatt means 110 to the power 6 watt. This much big power is generated. So how to transfer this? If we just pass this from the current, if we pass this current from this power lines, then whoever comes nearby, little bit also nearby, he will burn up. So what they will do, before sending power, they will put this like keep one like transformer. What it will do, it will reduce the power. Reduce, step down and step up. So near to a house which is required, it will be step up, then step down and step up. So there are two types of transformer in that. So we are not going in that detail. So I'm just giving you idea how alternate currents are generated.
So some will store some energy in it.
Yeah, and there will be some loss also, obviously, because this power, this alternate current cannot be taken back. Once it is sent, done, finish. It's only one way. But direct current, like in battery, how we are using, okay, in battery we are using sometime, we are keeping it as it is. Again, we are using sometime, again it's keeping as it is. So in short, we are using slowly, so it's not getting like wasted. But some appliances, as our house, as we are using on house, they require alternating current. Now, if you observe from your laptop, that is also required alternating current, but we have in between we have one adapter. If you have observed that, one big
Yes, sir.
square or rectangular box will be there, right? So that will convert, that will just do remaining work. That
So
your
it is the
battery should not,
converter.
yeah, your battery should not get damaged.
So it changes DC to AC.
Exactly. Now, in short, main work, why we are transferring alternating current, because direct current cannot be transferred for longer distance, but alternating current can be transferred. So let me write with this one point. We got 1 point. So let us write difference so that you can understand better. So difference, this is most important. Difference between AC and DC. First point, AC can be, we can transfer for longer distance, or we can say easy to transfer distance. But alternating current, sorry, DC current, DC
Sir, AC is for transfer for longer distance.
Yes, AC
Okay, sir.
transfer for longer distance. Even we can even see yes, even between two cities. But DC cannot travel for very long distance.
So sometimes they even give
So,
the
like,
electric
why
wires
the
in the.
so like why the like adapter in the computer like converts DC to AC?
Because our laptop is based on battery. If we remove battery, still we can use that current, but it will damage our application, sorry, appliances. Because it's like even in our appliances, if we are using laptop, then we have one chip, and that also we have one small battery that is DC.
Okay, sir.
12 voltage maximum it will be.
Sir, even they pass electricity through underground, also they keep electric wires underground.
Yes. So there are some more points also, but it's not for like 8th standard. It will be for higher standard. But I can give you small idea. Like this AC has some frequency, which no, let it be. We're not going that frequency part. Okay, as I showed you one graph before, it's going up and down, right? So it is plus and minus. So it is AC is moving in both the direction. AC means it is positive, negative, right? AC flows in both direction. But DC flows unidirection. Unidirection means single direction. In short, what is both direction means? Electrons are moving. Electrons are moving or keep changing the direction. Electrons are changing the direction. Electrons keep changing. Changing direction. But here, unidirection. So electrons will move only in what? Complete the statement. Electrons. Yes.
Will move only in one direction.
Exactly. Electrons moves in one direction. So, okay, so these 2 points we can remember.
Yes, sir.
Still, there are some more points, but you won't understand because for that you need to have little bit understanding of some more things, frequency and like cycles and all that, like how it rotates, how this generator works. We need to understand that. We'll study that later. Okay.
Okay, sir.
So now we saw AC-DC conversion. Now, what is electric potential, by the way?
Sir, the amount of electric current flowing through the circuit.
Yes, charge through a circuit. So if I say, let me.
Sir means its unit is also that Coulomb.
No, electric potential unit is not Coulomb. Only charge unit is Coulomb. So electric potential. So I'll give you, those who don't know this one, because if you haven't studied this one, I'll just give you a small idea. So there are there is a charge here, which is at infinity. We are bringing this charge to a point. So let's take a point as A. So Q charge is brought from infinity to a point A. So how much work is done? So how much we require to do some work? Like in short, like, see, we require some, if we want to push something, so I need to do some work to push that. Correct?
Yes,
Yes,
sir.
sir.
Right? I need some work. I need to do some work to push something. As I'm pushing my pen here, then only it is able to write here. So same manner, even charge is also required some work to do to move from one point to another. So that work done by the charge is potential energy, sorry, electric potential. So work done per unit charge, that is potential. Understood this one?
Yes, sir.
So if I give you in definition way, so amount of work done needed to move a unit positive charge. That is a definition we can say. Even by seeing formulas also you can make a definition. Amount of work done required or to move a unit positive charge. Unit means one charge. Right? Can you make this definition? Can you remember this definition?
Sir, can you write that definition?
Sure.
Thank you.
Amount of work required to move a unit charge. Okay. So I think so you have next class also. So let's continue on next class.
Okay, sir. Bye, sir.
Okay.
Okay, sir. Thank you. Bye. Sir.
Thank you, sir. Bye,
Okay,
sir.
sir. Yes, sir. Thank you, sir. Bye.
Thank you, sir. Bye.
Bye
Sir,
bye.
once can you share your screen? I will take a screenshot.
Oh yeah, sure. I think so I missed that. Oh yeah, no, I have.
Thank you, sir.
Yeah. Okay.
Yeah, over.